As we proceed, you can either unmute and speak to ask your question. You're also welcome to turn on your camera if you choose. While doing so, you can also type questions in the chat, and I'll try to monitor that. It is difficult to monitor the chat whenever I am sharing my screen. So if I miss something, somebody kind of speak up. Cassie, I know that you had emailed me about a question, I think in 8.1. So let's start with the question that you have, and then we'll get into other questions that Derek and Shay may have, or general questions related to the final exam.
Mr. Austin?
Ma'am?
It's it's at the very end of 7.2.
Okay, end of 7.2.
Yes.
Okay, is it one of the questions where you're trying to solve for? Let me share. I'm going to share my screen, and I'll go into lesson 7.2, and we'll try to find one.
Okay.
I
think I got it wrong.
Do you mind if I go into your lesson, because it'll be easier to find?
No, that's fine.
Okay. All right. Looks like at the end of 7.2, where you're solving equations, it only shows the one question you had, you got correct. Let's see if I can go into, was it a half angle maybe?
I think it's half angles. It looks like half angles because the question before was like, solve this using the half angle formula. But this one looks like half angles because it has theta over 2, but I don't know. There was something weird about it, and I can't.
Well, it looks like, at least on your homework, you got all the questions for your half angle correct.
Okay, so maybe it wasn't half angle.
Let me try a double angle. Okay, we did the question, the double angle question that you got wrong, you and I did the other night.
Yeah, it's the very last part of 7.2.
Okay, that's where you're solving equations in the factorial quadratic form. But it shows you got the question right.
That must be the one after that. You can't see that, can you?
It's not showing me any that you got wrong. It's only showing me that you got it correct.
Okay.
Let me see if I can go. Can you see my screen, Cassie?
Yes, I can. Okay,
hold on, and I'll see if I can go into that lesson, just a regular lesson, and see if we can find one that you're asking about. Okay. Instead of looking at yours. Okay, I want to go back to section. And you said it was 7.2.
Yes.
Okay. So let me get up here where I can preview it, and we'll go through it and see. Options, preview as a student. Okay, so the first question is a double angle. Let me ask Derek or Shay if they have questions about double angle while I'm here. Shay, Derek, do either of you have questions about using the double angle formula? Shay says no. Derek, are you okay? Can you type in the chat or unmute? Okay, I'm gonna keep going then.
It finally came off. I am having a little trouble with it. If you can go over one more time, that'd be good.
Okay. Does it matter whether I do tangent, sine, or cosine? Does it matter?
No, ma'am. Well, I mean, I understand that sine and cosine are together, but no, it doesn't matter.
Okay. Cassie, I'm gonna do this double angle, and then we'll keep going through this lesson until we get to your question, okay?
Okay, that's fine.
All right. So this question just is one that's in Newton. It came up, and it says, given that the tangent is 7/2, what is the tangent of 2 theta? So again, it's not overly obvious perhaps to you that we're doing a double angle, but the clue here that you're doing a double angle is that this is 2 times theta. Pretty much anytime you see 2 theta, whether it's sine or cosine or tangent, that's kind of the clue that you're going to do the double angle. So when you see something and it asks you to find sine of 2 theta or cosine of 2 theta, or as this one does, tangent of 2 theta, that's the clue that you want to use the double angle formula. Now remember, you do not have to memorize these formulas. Okay, on the final exam, you will have a formula sheet. This is the formula sheet that's in GoView under the final exam folder. I would strongly recommend that you print it off. Okay, so my tangent, I'm doing a double angle for tangent. My tangent double angle formula is right here on the page. I'm going to copy it down for myself and then take it over to my paper. Okay. And guys, I would tell you to do this. Yes, it's a little time consuming, but it is worth it to write the formula. I know that I need to use the tangent of 2 theta, which is 2 times the tangent of theta divided by 1 minus the tangent squared theta. So honestly, for tangent in this scenario, it's a straight flat out substitution problem because they've told you that the tangent of theta is 7/2. Let me make sure I copied that right. I didn't miss the sign. It is 7/2. So it's a straight flat out substitution. So I'm going to have 2 times 7/2. I replace tangent of theta with the value that was given to me over 1 minus that tangent value 7/2 squared. And then it becomes basically performing the mathematical calculations. You got to deal with a lot of fractions, and that's troubling to some students. In the numerator, we put the 2/1. So the 2 in the numerator and the 2 in the denominator divide out. So I have 7 in the numerator. In the denominator, I have 1 minus. I need to square 7/2. 7 times 7 is 49. 2 times 2 is 4. Then I need to combine that denominator together. I have to rewrite the 1 in terms of force. It takes 4 force to make a whole. So I have 7 over 4 minus 49 is negative 45 over the common denominator of 4. You now have a division problem. Okay, this becomes 7 divided by negative 45 over 4. And if you remember your rules for multiplying fractions, you're going to flip and multiply. So I have 7 times negative 4 over 45. I'm going to put the 7 over 1. We multiply the tops. 7 times 4 is 28. Positive and a negative make it negative. Over 1 times 45 is 45. My answer is negative 28 over 45. And in most cases, it is a straight, flat-out substitution problem. You okay, Derek?
Yes, ma'am. Yes, ma'am.
Okay.
Thank you.
You're welcome. All right, I'm going to keep moving. Cassie, are you still with me? Are you still looking?
Sorry, I was talking and I was still muted. I am.
Okay, so you got, I'm still in the double angle questions. Okay, now I'm going to the half angle questions, okay? So you kind of watch and see if you see one. I'm going to kind of go a little bit slow so you can tell me if you see what you were struggling with. Shay, are you and Derek okay with half angles, or do you need some help with those? And I think somebody else came in. Do y'all need to see a half angle example before I move on?
I would not mind seeing it.
Okay, I'm going to do this sine problem and see what Shay said. Example won't hurt. On the final, what do I expect to be the hardest? I would think some of the questions back in unit 5 and 6 where you had to do the transformations and things are going to be more challenging, or I would anticipate them being more challenging than the ones in 7 and 8, because honestly 7 and 8 comes down to plugging and chugging into a bunch of formulas. Okay, so it was 12 divided by 13, and we're in quadrant 2. We want to find theta. All right, so this is a question about a half angle. It says the sine of theta is 12/13 and theta is in quadrant 2. Then what is the sine of theta divided by 2? Now here again, it doesn't express, specifically say use the half angle formula. So again, the way to recognize that is you have your function, sine or whatever, and you're going to have theta divided by 2. Previously for the double angle, it was 2 times theta. Now it's theta divided by 2. So again, it doesn't explicitly say to do a half angle, but your clue is that your angle that they're asking for is being divided by 2. Again, the first thing I'm going to look for is my formula. And I believe I discovered the other day when I was looking at this on this formula sheet that is on the test for the final, the half angle formulas are missing. But I did also look, and there is not a half angle question on the final. There will likely be one on the online test 5, whichever test y'all got due this weekend. I think it's 4. Okay, so I just Googled it and told it I wanted the half angle formula for sine. Okay, so my half angle formula for sine is plus or minus the square root of 1 minus cosine x all divided by 2. Okay, so the half angle formula that we need, and again, I would encourage you to write it down, is the sine of theta over 2 equals plus or minus the square root of 1 minus the cosine of x over 2. Now, here's where it gets a little messy. You got a lot of little steps you got to do here. in the question itself, you've been given the sine of theta, not x, I'm sorry. Okay, but in order to use the formula, you need cosine. So we have a step here at the beginning. We're going to use the Pythagorean identity to find the cosine. Cosine theta. Okay, your Pythagorean identity, remember, is cosine squared theta plus sine squared theta is 1. I was given the sine of theta as 12/13. So I can substitute that into my Pythagorean identity. Okay, so I would have cosine squared theta plus 12/13 squared. 12/13 was the value I was given, equals 1 whole. So that gives me cosine squared theta plus square 12/13. 12 times 12 is 144. 12 times 13 is 169, equals 1. I'm trying to solve for cosine, so I'm going to subtract 144 over 169 from either side. To do the subtraction, remember, you have to have a common denominator. 1 whole would be 169 over 169. So we're left with cosine squared theta equals 169 minus 144 is 25 over 169. But that's cosine squared. We want just plain old cosine. So I'm going to take the square root of both sides, and it could be positive or negative. I'll have to decide that in just a minute. So cosine theta is positive or negative. I haven't decided yet. Square root of 25 is 5. Square root of 169 is 13. To decide whether it is positive or negative, you have to go back to the original question. The original question told us that theta, the angle, is in quadrant 2. So if I sketch this angle, I'm somewhere in quadrant 2. In quadrant 2, the x value is negative and the y value is positive. In terms of trigonometry, remember, that's cosine and sine. So in quadrant 2, the cosine is negative. So ultimately, the cosine of theta is negative 5/13. This is the answer, or the piece that I need. See, I had to do that preliminary step of finding the cosine before I can even think about plugging into the double angle formula. Now I can plug into that double angle formula, and I'm going to write it down again so you'll have it kind of right here together. We have the sine of theta over 2 is plus or minus the square root of 1 minus the cosine of theta over 2. So now I know that cosine of theta is negative 5/13, so I can plug and chug. So the sine of theta over 2 is plus or minus the square root of 1 minus negative 5/13 all over 2. And then I have to do the math, okay? Sine of theta over 2 is plus or minus the square root. Okay, you've got 2 in the denominator. You got minus a minus. I hope you realize that becomes a plus 5/13. 1 whole would be 13/13. So I have that's plus or minus the square root of 13 plus 5 is 18/13, all divided by 2. Now again, you have to realize that that's a division problem. You have 18/13 divided by 2. Using our rules for fractions, we got to flip and multiply. So we have 18/13 times 1 over 2. Which equals plus or minus the square root of 18 over 26. And I'm still not through because then I've got to simplify that radical. I'm going to change colors. I have plus or minus the square root of 18 over the square root of 26. Okay, 18 contains a perfect square. It becomes plus or minus 3 on the square root of 2 all over square root 26. Cannot have a radical in the denominator. So then you have to rationalize the denominator by multiplying the numerator and the denominator by that radical. So we have plus or minus 3 times the square root. 2 times 26 is 52 over square root 26 times square root 26 is just plain old 26. And I'm almost home free, but I do need to simplify my radical again because 52 is 4 times 13. So I'm going to have plus or minus 3 times 2 on the square root of 13 all over 26. But then I realize the 2 will divide out into the 26. 2 goes into 2 one time, 2 goes into 26 13 times. So I end up with plus or minus 3 on the square root of 13 all over 13. Then again, I'm down to the point where I've got to decide, is my answer going to be positive or negative? Okay, so here's where you got to kind of think it through for a minute, okay? If we go back up here to our picture, the original angle is in quadrant 2. If I take half of that angle, that's going to put me back into quadrant 1. In quadrant 1, the x value or the cosine is positive and the sine is also positive. So the sine of the half angle is also going to be positive. So ultimately my answer is the sine of theta over 2 is the positive 3 square root 13 over 13. We don't usually put the plus sign, so This is the final answer because it's a lot of steps and it's a lot of math. A couple of things that'll help you, you know, draw the diagram like I did to figure out your quadrant issue. Okay. I was doing a lot of the math in my head because I can. I've been doing this a long time. Okay. You know, if you need to get the calculator to square 12 over 13, get the calculator. You know, don't make careless errors because you didn't want to get the calculator out. But you have to do it step by step. I will mention, in case that's one of the pieces that you haven't caught on to, if you are given the sine of the angle, like we were in this problem, or the cosine of the angle, but you really need the other one. You know, they gave me sine, but I needed cosine. If they give me cosine and I need sine, then I can always use my Pythagorean identity. You can't forget those identities that you learned earlier. I think it was in Unit 6. Okay, you can always use the identity, the cosine squared theta plus sine squared theta equals 1. There's always, this relationship always exists between sine and cosine. Okay, so there's a half angle. Do you have questions before I continue?
Thank you. We good.
Okay, Cassie, I'm going back to the homework, and I hope you're still with me.
I am.
Okay, let me check my chat. Okay, so I'm going to keep going. Okay, here's the next half angle question. Okay, now I'm getting into the ones where you have to do the solving the equation. So that may be where your question was, Callie.
Yes, this is it.
Cassie, I'm sorry. This question?
No, you're fine. Yeah.
Okay, so here's the question, guys. We're solving equations that are what they call in quadratic form. And so there are a variety of ways you can solve those. I'm going to copy this over to my work. Okay, so this one says tangent squared of beta equals 1, given that you're between negative pi and it can be equal to negative pi and positive pi. Okay, so the first thing I'm going to think about doing is solving this equation. And again, there's a variety of ways. It's called the quadratic form because if you think back to algebra, in algebra you had things like ax squared plus bx plus c equals 0. Anytime you have an exponent of 2, it's called a quadratic. And we learned in algebra that when you have a quadratic, we can solve it by factoring, by using the square root property, which I've used a couple of times already, or using the quadratic formula. Okay, so those same things that you learned in algebra are now being applied to trigonometric functions. So for example, this question here where you have tangent squared beta equals 1, would be similar to having the question like x squared equals 1. Okay, so think about how you would solve that. We know that in order to eliminate a square, we can take the square root of both sides. So that's what I'm going to do. I'm going to square root both sides. Now remember, it could be positive or negative. So I have the tangent of beta equals positive or negative 1. I'm going to write it separate so that you realize that that's two possibilities. Tangent beta could be negative 1 or tangent beta could be 1. Formally, if you're doing it, very rigidly following the trigonometry rules, we then are going to take the arctangent of both sides so that we have beta equals the arctangent of negative 1 or beta equals the arctangent of 1. And when you're thinking about the arctangent functions, okay, they're really asking you where on the unit circle is the tangent negative 1 and where on the unit circle is the tangent positive 1. So at that point, you may want to pull out your unit circle. There is one on the formula sheet for the final, but you cannot read the tangent directly from the unit circle. That's the one function you can't read. So I'm going to help you out in just a minute. I'm going to give you a list, but let me write it down for myself first so I don't get myself mixed up. I'm writing it on my paper, so hold on just a second so I don't get mixed up. Okay, one of the things that may help you is to put this in your notes and have it handy while you're taking the test. Okay, I'm going to let me scroll down and put it on another piece and then I'll come back up. Okay, the tangent of pi sixth, any of your pi sixth is going to be square root 3 over 3. Now it could be positive or negative depending upon which quadrant you're in. The tangent of pi fourths is 1 and the tangent of pi thirds is the square root of 3. So if even if I'm at say 5 pi sixth, which puts me, okay, even if I'm at 5 pi sixth and it puts me in the second quadrant, my value is still square root 3 over 3, but it's negative because I have different signs, S-I-G-N-S, in quadrant 2. If I'm at 7 pi sixth, it would be positive square root 3 over 3. Any of my sixths are going to be square root 3 over 3. You have to decide based on the quadrant you're in whether it's positive or negative. Any of the fourths, pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths are going to be 1. Again, changing the sign positive or negative depending on the quadrant. And then the same thing with the thirds, pi third, 2 pi thirds, 4 pi thirds, 5 pi thirds will always be square root of 3. Again, you alter the sign based on the quadrant you're in. So that may be helpful to you to write down. So using that information, it's going to get a little wonky because in the original problem, it tells us that our answers have to be between negative pi and pi. So it's kind of weird. Okay, here's 0, here's pi. If you rotate in a positive direction, you're going to get the answers for quadrant 1 and for quadrant 2. Okay, in quadrant 1, the tangent is positive 1 at pi force. In quadrant 2, it is negative 1 at 3 pi force. Now, if I keep rotating positively, my other answers are going to be 5 pi force and 7 pi force. But those values are outside the range that they gave me. My answers have to be between 0 and positive pi, and then 0 and negative pi. And what you've done is instead of rotating positively, they started at 0 and they rotated negatively. 7 pi force is the same as negative pi force. 5 pi force is the same as negative 3 pi force. So I'm positive in quadrant 3, so that would be negative 3 pi force. And I am negative in the fourth quadrant, which is negative pi force. So you end up with 4 answers, but the 4 answers have to be between negative pi and positive pi. And that's the easiest way to look at it. You rotate positively around a pi, and then you rotate negatively around a pi, which gives you negative pi. It's all in the rotation. So your answers are 3 pi force, negative pi force, positive pi force, and negative 3 pi force. And I wouldn't think in terms of Newton, it wants you to put in the 4 answers, and I don't think the order that you put them in would matter. Cassie, are you still with me?
Yes, ma'am, I am.
Okay, so that was your question. So did you follow what I was doing?
Yes, I did.
Does anybody have a question about that problem before we move on? Okay, that was the end. That was the kind of the end of lesson 7.2, and Cassie had a question about it. But as we went through 7.2, I have done an example of the double angle and the half angle, and then solving the quadratic equations, or the equations in quadratic form. Okay, so let me open the floor then for other questions, perhaps related to units 7 and 8 or related to the final. Let me give you some background information about the final in case you haven't been reading the announcements or the emails. The final exam is actually scheduled to open tomorrow. I gave you a couple of extra days to do the online exam for, so it kind of overlaps. So you do have, tonight you have lesson 8.1 that's due. Discussion 4 is due, and your online exam 4 is due Sunday. Now, I do realize the exam technically opens tomorrow, and it will close on Wednesday, July 21st at 11:59. Those dates are set by eCore, not by me. The final exam is not proctored, so you don't have to make an appointment or anything like that. That also means that you're able to use your notes that you've taken throughout the term and your other course materials. The final exam does cover the entire course, units 1, 2, 3, 4, 5, 6, 7, and 8. There is about 9 questions from the first half from units 1 through 4 and 11 questions from units 5 through 8. About 9 of the questions are multiple choice, 11 are where you fill in the blank. One of the biggest issues students run into is you don't round to the specified number of decimal places. Don't panic, okay? I go in and look at each individual student's test for rounding errors. You know, if you were supposed to do 3 places and you only did 2, or you're supposed to do 3 and you didn't do any, I can look at that and make adjustments, but try to follow and pay attention to the instructions. You do have a formula sheet at the beginning of the test, okay? And there's one in the folder in GoView under Final Exam. That's the one that I've been referencing tonight. I would strongly encourage you, if you have a way to print one, to print it so that you can have it to look at. I suppose the biggest challenge is that there is a 2-hour time limit. And again, that is set by eCore, not by me. Let's see if I've got it. I thought I had it open, but maybe not. The practice final exam that is in GoView, you have to do because it's graded, but it also has similar questions to what you would see on the final, and it has the formulas that you may need while you're taking the test, all the way back to the beginning of the term. Cassie?
Oh, sorry. I know I have it written down in my planner. I just don't have my planner beside me right now. And I think you just said it. When is the practice final exam due?
I believe I have it set to be due the same time as the final exam, which is July 21st.
Okay. I just wanted to check.
Okay. Do any of you have questions in general about the final exam that I can try to answer? And then do you have specific questions from the practice, if you've worked through it, that you have, or do you have other questions from Newton that you need to see? You can unmute or you can type in the chat and I'll try to read it. Is there something that you struggled with at the beginning of the term from units 1 through 4?
And I have one more question. Sorry, I'm
okay.
full
That's
of questions. Fine. If like something comes up between now and the final that like I don't think of right now, can I still email you?
Yes,
or are you available?
I will still be monitoring my email.
Okay.
Throughout, over the weekend. Of course, I don't live on it 24/7.
Yeah.
But I will be checking it. So yes, you can still email me. And if we need to try to get on a quick Zoom call or something, I can do that. The biggest thing is on Monday, remember I do teach face-to-face, so it's tough to do anything on Mondays.
Okay, that's fine. I just wanted to check. Thank you.
Derek, have you and Shay had a chance to look at the practice final exam, or Cassie?
I have not yet. I just haven't yet.
Okay, I've got it up on the screen. So if you haven't looked at it, guys, I'm going to scroll through it so you can kind of see the questions. And as you look at it, think about, would you know how to work that problem? Okay. If y'all don't mind, I really would like to go through this first question because I know that the majority of students missed this type question on the midterm. So I would like to try to help prevent you from making that same mistake on the final. So if that's okay, I'm going to copy this one over so we can look at it. And it's not going to copy very pretty because it's a fraction, but oh my heavens. All right, let's not write it that way. I'll just copy it down and write it myself. Five x plus 2 all divided by x squared minus 4, 2x plus 1, and x plus 3. Okay, so this is a rational function, and it would be from one of the early lessons in the course, and it asks you to find the vertical asymptotes. But what many of you failed to remember on the midterm is that you have to simplify this rational expression before you find the vertical asymptotes. Okay, most students, and I don't know, I'd have to look back at y'all's paper to see if you'd made this mistake, but the mistake that most students make is they just take each one of these pieces in the denominator and solve for x. But what, again, most students fail to remember is you have to simplify the expression first. Okay, I immediately see that I have an x and an x, one in the numerator, one in the denominator. So those will divide out. That actually means at that value at x equals 0, there is a point of discontinuity. There would be like a little hole there in my graph, but it does not have a vertical asymptote at that point. The other piece may not be as obvious because I need to factor x squared minus 4. It factors into x plus 2, x minus 2. When I factor it, I then notice that I have the x plus 2 in the numerator and the denominator. So I would have a point of discontinuity at x plus 2, which would really be x equals negative 2. Okay, so I would also have a point of discontinuity at negative 2. The remaining pieces in the denominator, which are x minus 2, 2x plus 1, and x plus 3 are going to be the locations of the vertical asymptotes. Okay, so I should have a vertical asymptote at x minus 2 equals 0, at 2x plus 1 equals 0, and also at x plus 3 equals 0. And I got to solve each of those for x. Good old basic algebra. Add 2, add 2. So I have a vertical asymptote at positive 2. I have, if I do minus 3, I have x equals negative 3. So I have a vertical asymptote at negative 3. The other one requires just a little bit more work. 2x is -1, divide by 2, divide by 2. So x equals -1/2. So I actually have 3 vertical asymptotes and 2 points of discontinuity, but the question doesn't ask me about points of discontinuity. Okay, so I would only check +2, -1/2, and -3. So be careful. Again, that was one of the questions that I know a lot of students missed on the midterm. Okay, the next one asks you about finding horizontal asymptotes. Remember, there were 3 guidelines. You may want to make sure you have those written down. Okay, what about finding the F inverse with this fraction? I think a lot of folks miss this question as well. Are y'all good, or do you need to see it? Nobody is speaking. And nobody is chatting. Okay, I'm going to assume you guys know how. Yes, you want to see it, Derek? Oh, you have to go. Okay, that's fine. A lot of folks missed the one about the inverse variation as well on the midterm. So I'm going to run through that one. I'm trying to hit things that I remember that a lot of you guys missed. So hopefully you won't make the same mistake twice, so to speak. Okay, so this one says y varies inversely as the 4th root of x. Okay, so that first sentence kind of gives you the formula that you need. Now you have to remember that in general, the inverse variation is y equals k divided by x in general. This is kind of the general form. If it says it varies directly, the general formula is y equals k times x. But the sentence gives you the formula for this particular problem. It says y varies inversely as the 4th root of x. So that's your formula. And then they give you some values to plug and chug. It says when x is 81, y is 10. So we know y is 10. I don't know k, but I know the 4th root of 81. Now, you may not know how to do the 4th root on your calculator. There's a couple of ways to do it. Let me see if I can get my calculator to pull up. It's awfully slow when it comes up. While that's coming up, the easiest way to think about it, to put it into the calculator, is to write it with as an exponent. So this would be 10 equals k divided by 81 raised to the 1/4 power. That's the easiest way to put it into the calculator. Is my calculator going to come up? It's thinking about it really hard. Okay, so if I'm doing this on my calculator, again, the easiest way would be to do 81 raised to the 1/4 power, get out of the exponent, and hit enter. Yes, Shay, you can do that with all the roots. Even if it were a square root, I can do 81 to the 1/2. If it's a third, I could do 81 to the 1/3. You can convert any radical to a fractional exponent. Okay, so 81 to the 1/4 power is 3. Okay, so that means in my formula here I have 10 equals k divided by 3. I'm trying to solve for k, so I'm going to multiply both sides by 3. So 30 equals k. So my formula becomes y equals 30 over the 4th root of x. So then it says, what would be y when x is 17? So now that I have my specific formula for this problem, so here's my specific. This is specific to my formula. I can plug that in. So I have y equals 30 divided by the 4th root, and I'm going to put 17 to the 1/4, and it becomes a calculator problem. Okay, so on my calculator, I would have 30 divide 17 raised to the 1 divide 4 power. Make sure you get out of the exponent. And we get 14.77. And let's see, did it specify round to 2 decimal places? So if I'm looking at my calculator here, my second decimal place is a 7. Next to it is a 4. So I'm just going to leave it alone. So my answer becomes y equals 17.44. Okay, let's see what else we got. Finding the x coordinate of the vertex, that's a formula, plug and chug. Find all the zeros. Y'all stop me if you need me to work through it. Solving the equation log of -4 plus to the, that's an exponential. Then you have a logarithmic equation. Converting from radians to degrees. Finding the arc length. Okay, and I did see the formula for that on the formula sheet. Finding the value of cosine given cosecant. Finding the period of cosine. Question 13, by the way, they've corrected it now, but if you've already, you guys hadn't looked at it, so you should be okay. It did have the wrong answer, but they've corrected it now. 14 is a right triangle problem. Shay, you asked me earlier which ones will be the hardest. For a lot of students, the ones that will be the hardest are the word problems like question 14. (15, 16). Then you got your double angle, it tells you to use law of sines. Guys, here's the other thing. Look at question 18. Okay, question 18 is having you do law of sines, but it doesn't want you to figure out the whole entire problem. It wants you to stop when you have the sine of b. It doesn't want you to actually calculate what that is. It doesn't want you to solve for b. It just wants you to find the sine of b. So you're going to stop short of where you would normally carry it on out.
Can you work that one out, Miss Ralston?
Yes, ma'am. Let me see if it'll copy. I don't know if that triangle will copy or not. If it doesn't, I can sketch it myself. Okay, it's not going to copy, so let me write down the information and then I'll carry it over. Okay, so angle A is 30 degrees. Side A is 1.6. Side B is 1.0. Okay. Now, one of the nice things about that particular problem is it actually tells you to use law of sines. So you have what's called an oblique triangle, basically meaning it does not have a 90-degree angle. Let me see how it was sketched there so I can match it. Okay, so A's in that corner. Okay, this is angle A. This is angle B. This is angle C. Your angles are always labeled with capital letters. Your sides are labeled with lowercase letters, and they're always opposite. So I'm told in the problem that angle A is 30 degrees. I'm told that side A is 1.6. and side B is 1. Okay, and it tells me that I'm going to use law of sines. Okay, so law of sines, which is on your formula sheet, says that the sine of angle A compared to side A is equal to the sine of angle B over side B, or it could be equal to C. Okay, the three are equal to each other. If you set up the ratio of the sine of the angle to the length of the side, you can have any two of these ratios compared together. So for our problem, we're going to use this first half. We're going to, because we have information, you have to know 3 of the 4 pieces. Okay, so I know angle A, I know side A, and I know side B. Okay? So it's a plug and chug. I have the sine of 30 degrees. Ooh, fly, go away. Go away. Go away. Sine of 30 degrees over 1.6, which is the length of side A, equals sine of angle B that I don't know over the length of side B, which is 1. So I have basically a fraction equal to a fraction. It's called a proportion. We solve it by cross multiplying. Okay, so I'm going to multiply on the diagonal. So I would have 1 times the sine of 30 degrees equals 1.6 times the sine of B. Then I have to either use my calculator In this case, I can use my unit circle because 30 degrees is on my unit circle. So if I go and look at my unit circle, if it's not, I'm just going to plug it into my calculator in degrees. Make sure you're in degree mode, okay? But the sine at 30 degrees is 1/2. So I have 1 times 1/2 equals 1.6 times the sine of b. So that gives me 0.5. Half of 1 is 0.5 equals 1.6 times the sine of b. Then I'm going to divide both sides by 1.6 because I'm trying to get sine b by itself. So I have the sine of b equals, let me go out here to my calculator because I don't want to do that in my head. We would have 0.5 divided by 1.6, enter, and that equals 0.3125. Okay, so the sine of b is 0.3125. Now, for the question in the practice final exam, this is the answer they want. They want you to find the answer for sine b. So this is the answer you would enter. But guys, if you're doing your homework in Newton, you've got to go one more step. Okay, you've got to go and do the arc sine of both sides so that b is the arc sine of 0.3125 so that you can actually find the value of that angle measure. Now, again, remember, I'm going to check my mode. I'm in degree mode. When you're dealing with a triangle, you should be in degree mode. I'm going to do arc sine, so let me get out of this. Arc sine would be the second sine of 0.3125, close it, enter, and it's 18.2 degrees. Okay, so angle B, if I were doing this in Newton, I would have to enter the angle B, and so angle B would be 18.2 degrees. Okay, so be careful. It depends, you know, if you're doing your homework in Newton, you got to go all the way to finding the angle value. But the question, the way it's worded, and they even have it highlighted or bold printed there, that it wants you to find sine of b. It doesn't want you to go all the way to the end. They're saving you a few steps, which on the test itself would save you a little bit of time. Cassie, I think you asked me to work that, or was it you, Shay? I don't remember which one. Did y'all follow me?
Yes, ma'am.
Okay, then question 19 is actually probably a law of sines or a law of cosines. Okay, but it's.
Can you do that one? Sorry.
Yeah, hold on just a second. Let me write it down because my figure won't carry over. Okay, so side A is 950. Side B is 800. And angle C is 65 degrees. Okay, hold on just a second. Kind of sketching it here. Okay, so this is a word problem. Again, Shay, probably for most students, the word problems are the things that are going to give them fits. Notice, I think if I remember correctly going through this, I only saw 2 of them. Okay, so you have this lake, and we want to determine the distance across the lake from one side to the other side. So the surveyor marks off a spot that is A feet from one end and is B feet from the other end, and you have this angle in between, which is angle C. Now, this question doesn't specifically say to use law of sines or law of cosines, so you have to recognize that basically what they've given you, they've told you that A is 950 feet, B is 800 feet, and angle C is a 65-degree angle. So that basically what you have here in terms of your triangle is, you know, a side of the triangle, you know a second side of the triangle, and you know the angle in between. This would be the geometry scenario of side, angle, side, because I know a side, and the included angle. The two sides come together to make a specific angle. It's called side, angle, side. So I have to know that if I have that scenario, I have to use law of cosines, because I don't have enough information to complete the law of sines, and I'm actually looking for side C. Okay, this is what I want to know, because I want to know how far it is across the lake. But I don't have enough information to complete any of the ratios in the law of sines, so I have to use law of cosines. Now, when you look at law of cosines, and I'm fairly certain it's on this formula sheet, let me see. Yes, law of cosines, they give you 3 different formulas based upon which side you're trying to solve for. I need the one to solve for side C. So I'm writing my formula down. Okay, so the law of cosines, which I have to use because I have side, angle, side, and I'm solving for side C, is side C squared equals side A squared plus side B squared minus 2AB times the cosine of angle C. That's the formula. And I have enough information that I can plug and chug into that formula. I was told that side A was 950. I was told that side B was 800. Minus 2 times 950 times 800 times the cosine of 65 degrees. Now, guys, those are really big numbers, so I'm going to let my calculator do all of the work. I'm not going to try to do those huge numbers in my head. Okay, so we would type 950 squared. Whoops, I got 650, sorry. 950 squared plus 800 squared minus 2 times 950 times 800 times the cosine of 65 degrees, and I'm in degree mode, and I'm going to hit enter. And we get 900,120.6 0.2422 something. Let me get our faces out of the way. 2422. But now, guys, realize, okay, let me write that down for you so that you'll realize this. So C squared equals 900,120.2422. But again, that's C squared. We don't want C squared. We'd like to have plain old C. So we know to get rid of the square, we can take the square root. And typically we have to worry about whether it's positive or negative. So C equals, I need to take the square root of this number, so I'm going to do second square root, and then I'm going to pop my answer in there and hit enter. And I get 948.746691. Okay, let me go back to the question. How many decimal places? Okay, it doesn't tell me, but it's multiple choice. And I can see that my choices are rounded to 2 decimal places. Okay, so C is 948.746691. I can see that my answers are rounded to 2 places. Okay, so the 4 is in the second place. The 6 is next door, so it's going to bump it. This becomes 948.75. And there's our answer, and I think that was one of the choices. It was. Now, you have to be careful. It's not overly obvious necessarily in this problem, but when you're doing law of cosines, and in this case, we had to find C because that's what they were asking us for, but you have to be careful. But a couple of things to remember when you're dealing with oblique triangles. The longest side is opposite the largest angle. Okay, the longest side is opposite the largest angle. On the flip side of that, the shortest side is opposite the shortest angle. Okay, so that helps sometimes when you're trying to solve those triangles, because you kind of have that basic information. The longest side is opposite the largest angle, and vice versa. The shortest side is opposite the smallest angle. I think that was the last question on the final exam review. Yeah, there's only 19 on that one. The other thing that I would point out to you guys, under the content, if you go to the folder, final exam, and I'm too far down, okay? It has this practice final exam, but I also created a final exam review last semester for students. And so it's similar questions to what you have on the review. So it's kind of like extra practice. Okay. But I need to post this document, but I also have videos where I've worked out those questions. Okay, so there's some extra practice there. It's not graded, but if you're trying to prepare yourself for the final, working through those type problems, it'll give you some extras. And I hadn't actually posted the actual document. So I'll post it when we finish, so that you have that available to you as extra practice if you want it. You have to do the practice final exam. Okay, and you get 2 attempts. But then on the one that I'll post with all these, this goes with these videos, you can do that as many times as you want. And again, it's basically, I took the final exam, looked at the question, and then wrote similar questions so that you'd have the benefit of practice. So do you have other questions? Okay, I'm glad to know that, Shay, because it honestly, it takes a lot of time to do those. A lot of these I've done up over the semesters that I've taught this, but I'm glad to know that the videos can be helpful. Okay, it'll take a little while for the video tonight because it's almost an hour and a half long to process, but when it's processed, I'll post it in the course so that you can go back and look at the examples that we've done tonight as well. Other questions? Again, I'll be monitoring email and stuff over the next few days till y'all finish the final. Don't forget, tonight 8.1 is due. Discussion 4 is due. Your online exam 4 is due by Sunday, which it covers only units 7 and 8. And then you got your final exam to take before Wednesday at 11:59 p.m. All right, guys, if you don't have any more questions, I will stop the recording and we'll end the session. But if you have questions, you're welcome to email me and I'll try to respond to those.
Thank you so much for doing this too.
You're very welcome. You're welcome.